So we're continuing our quadratic formula conversation from yesterday. Yesterday's notes had this exact same formula at the top. Okay, it's printed again on today's notes. So this first line of the notes is exactly the same as yesterday's because we are using that same quadratic formula. Remember, this is the one I sang to y'all. What tune did it go to? Who remembers? Is the children's song? No. Pop goes the weasel. Y'all remember? Okay, I'm gonna do it one more time. So remember this quadratic formula. You can sing it to the tune of Pop Goes the Weasel to help you remember it. Okay, you've got to know this formula. If singing it to a tune in your head, I'm not saying you got to sing it out loud, but that'll help you remember it in your head. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so that's our quadratic formula. If you want to highlight again where everything goes like we did on yesterday's notes, we can do that again real quick. C is the constant in standard form. A is the coefficient in front of the x squared. It gets plugged in two places. And then your b is the coefficient in front of your x term. It also gets plugged in two places. Okay, so that's our formula for quadratic when we're solving quadratics. Okay. All right, just like yesterday's notes, this one has a worked example. The difference today, why are we talking about quadratic formula again? We just talked about it. Look at right here in the title. Okay, so the quadratic formula part is the same. Okay, so all of this is the same as yesterday, quadratic formula. What's different is this part right here. We're looking at it today with complex solutions. Okay, so it's been a couple weeks since we talked about complex numbers. We introduced them at the beginning of Unit 5 before Thanksgiving. So you may or may not remember, complex numbers were the ones that we wrote in the form A plus BI. Remember, the I was the imaginary part. A is the real part of the number. BI is the imaginary part. This is a complex number because it has an imaginary part. Does that ring a bell? Okay. So we're going to have some complex solutions, meaning imaginary. Meaning when we graph it in Desmos, we're not going to see the solutions. The graph is not actually going to cross the x-axis because the solutions are imaginary. So, unfortunately, like yesterday when we were checking our answers in Desmos, can't really check these in Desmos. Okay, so we have to be real careful with our steps and make sure we're simplifying correctly as well. Okay. Because when you go to try to plug this into Desmos, I'll show you. Excuse me. Okay, so this one that's worked out is 4x squared. Look at this. Does it cross the x-axis? No. So I can't even click on the x-intercepts and see if the decimals match, can I? That's what I mean when I say you can't check it in Desmos. Because in Desmos, the graph is going to look like it doesn't cross the x-axis. There's not a real solution. There's only imaginary solutions. So, one, if it's multiple choice and you plug your function in and it looks like this, and some of your choices don't have an I, eliminate them. This is definitely going to have imaginary solutions because there's no real solutions. Okay, so sometimes you can narrow down your answer choices just based on that. So, for example, in your assignment today, Some of them are multiple choice. So this one, for instance, see how this has two answer choices that are irrational, and it has two that are imaginary. See, they have the I in them. I can just look at this graph and narrow it down to two of these, because either there's real solutions or there's not. It either crosses the x-axis or it doesn't. Do y'all understand what I'm saying? Okay, so you can either eliminate these two or these two real quick by just looking at this graph to see if there's real solutions. Does the graph cross the x-axis? Okay, so you can use that to narrow down your choices, but you can't really check the exact values. Okay, so let's take a look then. Here is just another example worked out. They identified their A, B, C, plugged them in. Now, the only difference here from what we did yesterday is that we got a negative under the square root here. That's what makes this complex. Okay, that's what's going to give us that I, is that square root of a negative. Because what you have to remember is that I is the square root of -1. That should ring a bell. We talked about that at the beginning of Unit 5. Okay, I is the square root of -1. So if you end up with a negative under your square root, that's where I comes from. So you can see what they did is they replaced the square root of -7 with the square root of 7i. Pay close attention to the fact that this I is not under the radical. Okay, I was just helping a student in Cat Tracks with her homework, and she's like, I typed this in, I don't know what's wrong. She had it written correctly on her paper, but she was getting it wrong in Delta Math because she was typing and she typed square root of 7i. It wasn't 7, it was whatever it was. But she typed her square root, her number, and then her I, and the I was under the radical, and that's why it was wrong. So when you're typing your answers in, you type your square root of your number, make sure you arrow out from under the radical, and then type your I. The I is not under the radical. The negative was under the radical, but we took it out and it became I. Does everybody understand that? Okay, so that is the difference from what we were doing yesterday. Everything else is the same. Okay, now you will notice when they broke down their answers here, they did separate the A plus BI. Instead of leaving it all together over 8, they separated it out, okay? Because we want complex numbers in that form, A plus BI, if we can help it. So let's try one. So the first thing we need to do is identify A, B, and C. Okay, so what is my A? 3. Good. What is B? Say that again. -1. There is no number in front of that X. It's an understood 1, but you got to make sure you get the sign in front of it. What's C? C is the 4. Okay, so in quadratic formula, -b plus or minus the square root b squared minus 4ac all over 2a. Okay, so my C goes here. That came from that. A's here. And my B goes here. All right, so that's -1, 3, and 4. Everybody good? This is what we did yesterday. No questions? All right, now we simplify. So the negative becomes positive here. So that's 1. My denominator, 2 times 3 is 6. So I've just got to figure out what that simplifies to under the radical. And I can use Desmos. I don't have to do all this in my head. I can type what's underneath there all in Desmos. Make sure you use those parentheses like we talked about yesterday, because -1 squared is +1. And if you don't type those parentheses, it's going to do -1. Okay, so careful. So that's a 1 minus 4 times 3 is 12. 12 times 4, 48. So 1 minus 40. So this is -47. So here's where we got yesterday. And if the number was a prime number, we were done, right? There was no simplifying. Okay, 47 is a prime number, isn't it?
Yes.
So I can't simplify the square root of 47. However, what is special about this is that negative. That negative is going to come out. So this is 1 plus or minus square root of 47 over 6. And that negative comes out and becomes I. Now, some people like to write their I in front of the radical so it doesn't look like it's underneath. That just makes it very clear that the I is not under the radical. If you prefer that, that's technically correct also, okay? But complex numbers typically are written in A plus BI form, so I always have my I at the end, okay? So I'm going to separate this out now. Instead of having it all in the numerator over 6, I'm going to separate the 1 over 6 and the square root of 47i. Okay, so we're going to separate this so it looks like A plus BI. So my A is 1/6, got my plus or minus. Then my B is square root of 47 over 6, I. So now it's in that form, A plus BI. It's in the correct form. Now, I just leave my answers like this with that plus or minus symbol there. If you prefer to separate it out and write it as 2 answers, that is totally fine. You could write this as 1/6 plus the square root of 47 over 6i and 1/6 minus square root of 47 over 6i. That is also correct. I just like to write less and just put a plus or minus together. But that's up to you. So far, so good? All right, let's try one more like that. What is A?
6x squared.
It's just the number in front of the x squared, so just the 6. B?
Wow.
Good. C is 4. All positive this time. That's nice. Let's see if that makes it any easier. So B squared plus or minus the square root. Oh, I don't know why I just put that squared there, y'all. I am mixing up my formula. Negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so if you want to do your highlighting, do your highlighting. All right, so B was actually positive this time, which means when I simplify, it's going to be negative because it's negative B. All right, so under the radical this time, got 5 squared is 25. And then 4 times 6 is 24. Times 4 again is 96. So we've got 25 minus 96, negative 71. Is 71 a prime number, or do I need to do a factor tree to simplify it? It's prime, okay? If you don't know that it's prime, you just play in Desmos, figure it out. 71 divided by 3, 71 divided by 4, 71 divided by 6, by 7, by 8, by 9. Figure out if anything divides out evenly. Notice that I skipped 2 and 5 because y'all got to know it's only going to be divisible by 2 if it's an even number, and if it's only going to be divisible by 5 if it ends in 5 or 0. Okay, so you should be able to know if it's going to be divisible by 5 or 2 right off the bat. Okay, so this is a prime number. It's not going to simplify, but that negative is going to come out as an I. Ladies, I need y'all to stop your side conversations, please. All right, so we've got negative 5 over 12. Now I'm separating and simplifying in one step here. Square root of 71 over 12. And then what am I missing?
The I.
The I. That negative came out as an I. Okay, and I separated the A plus BI form. Questions right now before we go on to the back? Okay. All right, just like yesterday, when we flipped over to the back, all of a sudden our equations, our quadratics, are not in standard form. So what do I have to do to put this in standard form? I need to move that 24x over to the left. How am I going to move it?
Fine.
Okay, so it becomes minus 24x when we move it over to the left. So now our equation is set equal to 0, which is what we wanted. So now we can identify our A, B, and C. What is A? B? C. Perfect. Thank you very much. All right, negative B plus or minus the square root of B squared minus, whoa, get out of here. 4AC all over 2A. Okay, that's going to become positive 24. 6 in the denominator, so I just need to figure out what's under that radical. So you can use Desmos and type that in. Just make sure you type in the parentheses. If you don't type in the parentheses, it's going to calculate that wrong. So we've got minus 4 times 3 times 51. We end up with negative 36 under here. That's beautiful. Why is that beautiful? We have not had one like this yet. 36 is a perfect square.
To 6.
Yes, the square root is 6. So I say it's beautiful because that's going to make it nice and easy. I'm going to be able to get rid of that radical completely. I don't have to have a square root in my answer anymore. Okay, so there is a negative. I need to pay attention to that negative. What's that negative going to come out as? An I. So don't forget there's going to be an I for sure. But when I take the square root of 36, it's just 6. Didn't write that I in a very good spot. Let me move it. Now, can I simplify these fractions though? You can separate it first, or you can simplify it first. It really doesn't matter. That's kind of personal preference. Okay, if you wanted to separate it first, you're doing 24 divided by 6, and you're doing 6 divided by 6. What's 24 divided by 6? 4. You were right. And 6 divided by 6? Not times, we're dividing. Anything divided by itself is 1. Anything divided by itself is 1. Yep, you got it. Now, if it's 1i, do I have to write the 1? No. I is the 1. Yeah, I don't have to put a 1 coefficient in front of it. You treat it like any other letter. So if your coefficient's 1, you don't have to write it. That's much prettier than those answers on the front. That's why I said this is beautiful when I saw that 36 under the radical. If you end up with a perfect square there, it should come out nice and pretty. Feel okay about that? All right. Now a couple application problems with quadratics. Again, just like yesterday's, I'm going to use Desmos. Yes, you can use quadratic formula for these. And maybe that's what the intention was here because it's on our quadratic formula notes. But if I can use Desmos, that's a lot easier, isn't it? Y'all agree? Okay. So I think if I can, I'm just going to use Desmos. Now, if you tried to use Desmos and you couldn't figure it out, or the answers came out, those ugly decimals, then yeah, we'll go back and we'll use the quadratic formula. Okay, but here, this one is telling us that League City Little League has a season that consists of 90 games. The equation below represents the relationship between the number of teams in the league, X, and the total number of games played during the season. Okay, so here, get my highlighter here, they say that the number of teams is the X. And then the question asks us to find how many teams are in the league. So they're asking us to find X, aren't they? This is saying solve for X. So solving for X in this quadratic, because this is a quadratic that they gave us, how would I solve for X? There's lots of ways to do this. What's one way I could solve for X? Subtract that 90 over to the other side, right? To get it equal to 0? Because that's how I'm going to use Desmos. If I'm going to type this equation in Desmos, I need to have it set equal to 0. So I'm going to move that. Whoa, hello. Look how tiny that zoomed out. What in the world could we possibly use that for? That doesn't even make sense. This is fun. It's just a game. Here we go. All right. So I'm going to subtract the 90 to the other side. So we've got 0 equals x squared plus x minus 90. Now I'm going to use Desmos. And solving for x, when we solve for x, what is it we're finding on the graph? The x-intercepts. So if we want to solve for x, that means just what are the x-intercepts? Graph it. What are the x-intercepts? That's all it's asking. So I'm going to go to Desmos. And I'm going to type this equation in. One is x squared plus 5 plus x minus 90. Okay, so here's my graph. I got to zoom out to see this graph, but here's the graph, and I see 2 x-intercepts. So tell me, in the context of this problem, does a negative answer make sense? No. All quadratics are going to turn, okay? So you have to pay attention to the context of the problem. Like on yesterday's, I don't know if y'all remember yesterday's or not. It was the rocket shooting up and we were looking for when it hit the ground, and the graph looked like this, and it was asking how long it took. It did not make sense to have a negative answer because the x-axis was the time in seconds. So you're not going back in time. So we were only worried about that positive intercept. That's the same thing here. The negative intercept does not make sense in the context of this question. So if you want to show what the graph looks like, you can. We got solutions at -10 and 9, but we understand logically that the -10 doesn't make sense. Only the 9 does. So there are 9 teams in the league. Now, E says a baseball is tossed in the air from a height of 40 feet. The height h of the ball in feet is given by this function, where t is the time in seconds. What is the maximum height of the ball in feet? I will tell you, when I did this with first period, I realized there's a typo. Okay, and I'm actually gonna show you how we figured that out, that there had to be a typo, because it did not make sense in the context of the problem. And this is what I'm talking about. When you have application, word problems, things need to make sense. Okay, don't have some obscure answer that doesn't make sense in the context of the problem. Okay, so this one is very similar to the rocket. You're launching something, in this case, throwing something. It's going to go up, and what do we know from physics? What goes up must come down. Okay, so the ball is going to go up. It's going to reach a maximum height, which is what we're asked to find, and then it's going to come down and it's going to hit the ground. Okay, so this should be an upside down parabola, correct? So let's go check it out in Desmos. So we've got -6, and we're using x instead of t. -16x squared. And then this said minus 32x plus 40. So here's where I realized, this doesn't make sense. Because they're saying a ball is launched from a height of 40. So it starts at 40, but this has the maximum on the left side. It has the maximum with negative seconds. Does that make sense?
No.
No, that's how I realized this doesn't make sense. There's a typo here. And the typo is that this in front of 32 is supposed to be a plus, not a minus. So if I change that to a plus, see how it shifts it over?
Yeah.
So it's launched or thrown from a height of 40. So they start here. Maybe they're on a hill or a building. I don't know. They throw the ball here, and the ball goes up. Here's the maximum. And
what?
Yeah, it goes from 40 up to 56, and then the ball falls down. I'm going to zoom out, and the ball hits the ground here. This was 0 is the ground. Now, if the question was like yesterday's, how long did it take for the ball to hit the ground? Our answer would be down here. But the question today is what? What are they asking us for? What is the maximum height? Remember, height is represented by the y, so it's the y value here at that vertex.
I keep falling.
Oh, that's all right. Thank you. So my answer here is 56. Let me sketch. This is what it looks like. The negative doesn't make sense, but that's not even what it's asking for. It asks for the maximum, which happens at 156. I'm going to fix in my problem here that typo. Make sure you change that to a plus sign there. I'll actually rewrite it with y and x instead of the t. So I used Desmos again. And the height was 56. 6. How we feeling about these quadratics? Okay. All right. Your practice today is a mix of yesterday's, which was the basic quadratics, and then today's, which has the imaginary numbers, those complex numbers. Okay, so when you look at it, guys, hang on. Y'all stay quiet for one more second while I can explain the breakdown of the assignment. So it's today's date. I opened it yesterday. I told y'all could get a head start on it if you wanted to, because some of it was based on yesterday's notes. So you could have answered, I think these two, because these all say quadratic formula, but I programmed the assignment so that these two are rational, these two are irrational, and then these are complex. So it's different types. So like these two are like from yesterday's notes, okay? And then this one is from today's with the complex numbers. Now the multiple choice is a mixture, okay? So there may be some with imaginary numbers, there may be some that don't, okay? So the multiple choice is a mix, but these are going to be real solutions. These are going to be imaginary, okay? So you've got the rest of class today to work on those. Some of you may have started it yesterday in Cat Tracks or today in Cat Tracks. It is due the 5th, that is Thursday by midnight. So you have tonight, tomorrow night, and Thursday night to work on whatever you don't get done in class or Cat Tracks, okay? There should be plenty of time to finish that. It's not a super long assignment. Okay, so that's what you should be working on right now.